Good afternoon, this is Mr. Precella, and today I'm working the review for the first Math 314 quiz. And problem number 1 looks like it's an imaginary number problem. The square root of negative 25. Well, there's not a whole lot of paperwork, to get this answer. We said that the square root of a negative number is an imaginary number. So the square root of negative 25. Well, the square root of 25 is just 5. The square root of a negative is an imaginary number. So 5i is our answer there. 5i. Check it and move on to the next one. Now, the square root of negative 180. The square root of a negative 180. Well, 180 is not a perfect square. Let me see if I can adjust this like that. Okay. 180 is not a perfect square. If you're not sure of that, just punch it into your calculator, just the square root of 180. If you punch in the square root of negative 180, you're probably going to get an error warning, depending on the type of calculator, that says something like this: non-real answer. That means it's an imaginary number, and this calculator only works with with real numbers. If we looked at the square root of 180, you'll notice it's not an integer, it's a decimal number. Oops, let me clear all of that. The square root of 180. So it's not as easy as problem number 1, but it's not difficult either. First of all, let's take care of this I. The fact that we're looking at the square root of a negative number means we're going to have an imaginary number. So I'm going to go ahead and stick an I here, just to take care of that. Now, to simplify square root of 180, we'll write it as perfect square times a number. Let's find the biggest perfect square that divides evenly into 180. The perfect squares are 4 times 45. Maybe there's a bigger one, though. 4, 9. 9 times 20. 16. I'm just going, no, not 16. So far, 9 is the biggest perfect square we've found. 25, no. What about 36? 36 times 5. So I could rewrite this square root of negative 180 as 36 times 5. And now let's follow the colors. The square root of 36 is 6. I'll write this in standard form, putting the I in front of the square root of 5. Okay. So 6i square root of 5. Let's punch it. Well, wait, let me do this. Okay. And let me punch in. Oops. Let me get this calculator out of the way. 6i square root of 5. Okay. Let me just get rid of the calculator for right now. Okay. Add and simplify. Here we're adding together two complex numbers. We have the complex number 6 minus 4i plus 3 minus 2i. To add complex numbers, you just combine the like terms. The 6 plus 3, that would be 9. So I've added the real part. And then add the imaginary. Negative 4 plus a negative 2 would be a negative 6i. Be careful. Don't subtract the 9 and the 6 because those aren't like terms. So 9 minus, oh, look at this. I forgot to switch over here. To add complex numbers, you add the like terms. Add the real numbers, 6 plus 3, and then add the two imaginary numbers. Negative 4 plus a negative 2, negative 6i. Be careful, don't subtract the 9 and 6. Don't get a 3. You can't combine the 9 and the 6 because they're not like terms. 9 minus 6i. Oops, I. Check it. And I'm just getting over a pretty serious illness. And every time I find myself about to cough, I'll be pausing the thing so you don't have to hear my coughing fits on the video. So problem 4, negative 2 plus 7i minus negative 5 minus 7i. Well, negative 2 plus 7i minus negative 5 minus 7i. Well, in order to add complex numbers, you just combine like terms. To subtract, there's one extra step. You're going to have to distribute this minus before you combine the like terms. So we have a negative 2 plus 7i, distributing the minus, that would be a plus 5 and a plus 7i. And now combine the like terms. Add the real numbers together, then add the imaginary. Negative 2 plus 5 is a 3. 7i plus 7i is a 14i. Don't add the 3 and 14 to get a 17. Okay, so 3 plus 4i. Over here. 3 plus 4i. No, plus 14i. Wait, I said 4, didn't I? Number 5. This is a multiply problem. We're multiplying two complex numbers. Let me write it down. 4 plus 5i times 2 minus 9i. 4 plus 5i times 2 minus 9i. Oh, that's too dark. There. Well, to multiply complex numbers, we're going to FOIL this out. And then, before you combine everything, replace every I squared with -1. So foiling out, let's see what we'll have. We'd have an 8 minus 36I, then a plus 10I, and a minus 45I squared. Before we combine anything, if we replace this I squared with a -1, -45 times -1, that's just going to be a positive 45. So change the sign on the 45 and the I square is gone. And now add 8 plus 45 is 53. -36I plus 10I is -26I. So 50 minus 26I, 50 minus 26I. Let's see if I can make this a little bigger for y'all. There. I'll check my answer. Oh, wait. Oh, what did I write wrong? 50? Oh, it's 53. I'm sorry about that. 53 minus 26I. I typed the wrong answer in. 53 minus 26I. Okay. Now, problem 6. It says, factor this trinomial. R squared minus 18R plus 80. R squared minus 18R plus 80. Well, in order to factor trinomials, we're going to write out 2 sets of parentheses. And I'll decide on the sign. It's right off. The second sign is plus, so we want the last two numbers to multiply together to give a positive 80. So that would either be plus plus or minus minus. Look at the first sign to decide. It's a minus minus. The second sign is plus, 2 of the first sign. So R and R. Now, let's think of numbers that multiply together to give 80. There's 1 times 80, 2 times 40. There's an obvious one that you might notice is probably going to work. 4 and 20, and what's that obvious one? Well, there's 5 times what? 80 divided by 5, is that 16? 6 doesn't divide into 80. I'm thinking it's 8 and 10 that are going to work. If you FOIL that out, we get R squared minus 10R and minus 8R is a minus 18R plus 80. So R minus 8 times R minus 10. R minus 8, oops. R minus 8. No, don't forget to put the parentheses. Times R minus 10. Okay, here's another one. Notice number 6 and 7, it just says factor. It's not an equation that you have to solve. There's nothing there about solving an equation. Number 7. R squared plus 3R minus 40. This is another simple trinomial. By that I mean there's not a number in front of the R squared, so it'll be a little easier to factor. Okay, just like number 6, no number in front. It's when you have those numbers in front of the square term, that it can be a little bit more difficult. So r squared plus 3r minus 40. Well, the second sign is minus, so we want numbers that multiply together to give a negative 40. So that means 1 plus and 1 minus. So I'll wait to fill them in. I'll put an r here and here to get the r squared. Now thinking about numbers that multiply together to give 40. 1 times 40, 2 times 20, 4 times 10. What's that obvious pair that's probably going to work? The 5 and 8. If we subtract 5 and 8, that'll give us that middle term. So how will I need to arrange my plus and minus sign in order to get a positive 3? Well, then the 8 would need to be positive and the 5 negative. And you can FOIL that out in your head to verify. You have r squared, then a plus 8r and a minus 5r, giving you a plus 3r, and minus 40. So r minus 5 times r plus 8. Parentheses. R minus 5 times r plus 8. Notice, once again, that's just saying factor. It doesn't say solve an equation. This one here, too, you're just factoring it. We write it down. Number 8. 2w squared plus 11w plus 5. 2w squared plus 11w plus 5. Okay. To factor this, I'll write down my 2 sets of parentheses and decide on my signs. Second sign is plus, so 2 of the first. Notice this is not a simple trinomial because there's a number in front of the squared term. It's not a big number. Numbers that multiply together give 2, 1, and 2. Numbers that multiply together to give 5, 1, and 5. So I'm just going to say w times 2w. And how will I need to arrange the 1 and 5 if I'm going to get an 11w as the middle term? Well, if I put the 5 here, I think I'd just be getting 7, not 11. If I put the 5 there and the 1 there, that would give me a 10w and a 1w. Do those add together to give us 11w? Yep. So there it is. W plus 5 times 2w plus 1. Now make sure you notice the instructions. There's not an equation. It doesn't say solve. If it says factor, your answer is going to be 2 sets of parentheses. A lot of times students will miss the problems on the tests or quizzes because then once they get to this point, they'll set each one of these to 0 and get -5 and -1/2. No. You're not asked to solve an equation. If it just says factor, your answers are 2 sets of parentheses. The instructions are important. Okay? Oops. Coming back over here. 2w plus 1. Check it. Yeah. Let's see. Next question. Number 9 says to factor it. Oh, this one's a little tricky because it's not written in the form it should be. It's not written in that descending form. It should be written c squared c constant. So the first thing I will do on this one is write it in the form 3c squared, then a minus 8c, and a minus 3. And I'll draw my two sets of parentheses. Notice how it's always in standard form, r squared, or a descending form. R squared, r constant. W squared, w constant. Up here, r squared, r constant. That's why we needed it. C squared, c constant. Let's see, numbers that multiply together to give 3. Well, there's not that many. 1 times 3. The second sign is minus, so that means it's going to be a plus and a minus. I'll wait to fill that in. So I'll say C and 3C. And if this is going to work out correctly, all we can do is just use a 1 and 3. But can't have a 3 over here because you can't have a common factor in the same set of parentheses. And if you put a C right here, you would have a common factor of 3. Oh, okay, I'm back. So the second sign is negative, so 1 of each. We can't put a 3 there because it would be a common factor, and we can't have any common factors other than 1. So we're going to make this work out. There's going to have to be a 3 there and a 1 there. Now, how will we arrange if we look at the inner and the outer on FOIL? How are we going to arrange it so we get a negative 8c? Well, going backwards, the 9 would need to be negative and the 1 positive. So that would put a negative here in front of the 3 and a plus in front of the 1. And you can FOIL that out to check it. So parentheses, c minus 3, close parentheses, open parentheses, 3c plus 1, close parentheses. Okay, notice how these instructions are different. It doesn't say solve. It doesn't say factor. It says solve. And look over here, t equals. We're going to actually be finding the number for t. We're not just going to stop with the two sets of parentheses like we were doing on the other ones. So problem 10. T squared plus 7t equals 18. T squared plus 7t equals 18. Well, to solve this, we have to put it in the descending order. Just like over here on these, they have to be in descending order. For number 9. And we need a 0 on one side of the equal sign. So I'm going to move this 18 over. T squared plus 7t minus 18 equals 0. Well, numbers that multiply together to give 18. 1 times 18, 2 times 9, 3 times 6. This is a trinomial that's easy to factor because there's not a number. So you just look which pair of numbers subtract to get that middle term. I'm thinking it's going to be the 2 and 9 that work out. So we have a t and a t. Second sign is minus, so 1 plus and 1 minus. I'm going to use the 2 and 9. in order to get a positive 7, that would mean that the 9 needs to be positive and the 2 negative. If you FOIL that out, we'd have a t squared plus 9t minus 2t. 9 minus 2 gives you the 7t minus 18. Then set each one of these factors to 0, and we get t equals 2. Now, why are we doing this extra step here? Because we're solving an equation. It didn't just say factor. This brings me back to a time years and years ago when a waiter at a restaurant I was eating at told me his math teacher was so stupid because he told him that they needed to study the instructions. And I tried to tell him, oh, no, wait, that's actually a very good idea. I'm going to start telling my students that. And that waiter walked away thinking, oh, that idiot, it's another one of those. But notice the difference, okay? If it just says factor completely, or factor, then your answer is the 2 sets of parentheses. You stop. You don't set them to 0. If it's an equation with an equal sign in it and you're solving, then you actually get, you set the parentheses equal to 0 and you get 2. Let's see, what are those answers I got? A 2 and a negative 9. Okay. Number 11. Hopefully you can tell from the instructions, this is going to be another one where you actually solve it and get numbers as answers, not 2 sets of parentheses. B squared plus 5b equals 36. Be very similar to what we did up here. Move the 36 over to get a 0 on one side. There's not a number in front of b squared, so this is an easier type to factor. Numbers that multiply together to give 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Second sign is minus, so there'll be a plus and a minus. There's not a number in front of the b squared, so you just go b and b. And this is one of those easier ones. You can just sort of look at the pair of numbers and figure out which pair will subtract to give you a 5. Well, 4 and 9. How do I arrange the plus and the minus in order to get a positive 5? Well, it would need to be a positive 9 minus 4. Then set each one of these to 0. And we get b equals 4. And b equals negative 9. So 4 and negative 9. Or negative 9 and 4, however you want to write it. 4, comma, negative 9. Okay, number 12. 6x squared plus 11x equals 72. Solve this equation. Okay, well, we got to move the 72 over. Got to have a 0 on one side. And this is not a simple trinomial. There's a number in front of that x squared. So numbers that multiply together to give 6. So 1 and 6, 2 and 3. Ooh, a lot of numbers multiply together to give 72. 1 times 72, 2 times 36. Ooh, let's see, what's 72 divided by 3? Oh, let's see. Is it 24? How about 4 times 18? 5 doesn't divide into 72. 72 divided by 6 is 12. Okay. 7 doesn't divide into 72. There's one more pair. 8 times 9. Is that all the pairs that divide into 72? So let's draw our 2 sets of parentheses. Draw the 2 sets of parentheses. I think I'll start with the 2 and the 3. I don't see anything really obvious right off. I'll just say 2x and 3x. That's what I'm trying. Second sign is minus, so there's going to be a plus and a minus. I'll try the 8 and 9. That doesn't work. I'll try the 6 and 12. Let's see. 8 and 9. If 8 and 9 are going to work, we would have to have the 8 with the 3 because you can't have an a common factor. So let's try it like that. If I look at these numbers here, that's a 27x and a 16x. Oops. You know what? I put a dot right here, and now that minus looks like a equal sign. That's a minus there, okay? Well, can we subtract these numbers to get that middle term? I think so. 27 minus 16, wouldn't that give us a positive 11? So if I'm going to get a positive 27, that would mean I need a plus here and a minus right there. Now see how I FOILed that out? So it'd be a 6x squared, then a minus 16x and a plus 27x. That gives us the positive 11x and then minus 72. Now set each one of these factors to 0 and isolate the x. So 2x plus 9 equals 0. Move the 9 over and divide by 2. So negative 9 over 2 is one of the answers. And what's the other one? When I set 3x minus 8 to 0, I move the 8 over and then divide by 3 to get 8 over 3. So negative 9 over 2 and positive 8 over 3. I sort of had to write small to get it all out on that page. So negative 9 over 2. Oops, what did I do? Negative 9 over 2. I'll hit the right arrow to get out of that fraction, comma, 8 over 3. And I will check that answer and move on to the next problem. This is an absolute value equation. So Let me write that down. 13 absolute value of 4x minus 3 equals 8. This is not 14x minus 31 that I'm writing. You see? Okay. Not 14x minus 31, absolute value bars. Well, the logic to solve this equation is to know that there's really only two numbers that can be inside here. What are the only two numbers that have absolute value equal to 8? Well, 8 or negative 8. So take what's inside the absolute value bars, set it equal to positive 8, then set it equal to negative 8, and go through and isolate the x. We move the 3 over, so we get 4x equals 11, divide by 4, to get 11 over 4, and then doing the same thing over here. Move the 3 over, so we have 4x equals, is that going to be a negative 5? And then divide by 4 to get a negative 5 over 4 and a positive 11 over 4. So 11 over 4 and negative 5 over 4. 11 over 4, right arrow to get out of that fraction, comma, negative 5 slash 4. Check your answer. Number 14 is another absolute value equation. Let's see. Absolute value of m plus 9 plus 4 equals 22. Well, to solve an absolute value equation, you have to have those absolute value bars isolated, like on number 13. Here, I need to move that 4 over so my absolute value bars are by themselves. Then I'd have absolute value of m plus 9 equals 22 minus 4, 18. Now it's very much like number 13. You use the same logic. The only number that can be inside those absolute value bars is either 18 or negative 18. So you solve the equation, m plus 9 equals 18, m plus 9 equals negative 18. So let's see, move that 9. 18 minus 9 is 9, so there's one answer. Subtracting the 9. Is that negative 27? So positive 9 and negative 27 are your two answers there. Positive 9. Positive 9 and negative 27. Okay. Number 15. Number 15 says solve, and notice it has a greater than symbol in here. So this is an inequality, and we're going to be typing our answer in interval notation. That's when you use the number line with all of the infinity symbols and so forth, the parentheses, the brackets. Let me write this problem down. X minus 1 over x minus 14 is greater than 3. To solve something that has a less than or a greater than symbol in it, you're going to be using what we call the cut point method. So we'll start off finding the solution cut points. I'll abbreviate those SCP. To find the solution cut points, you put an equal sign and then just solve it as an equation. I think I'll just cross multiply. I'll have 3x minus 12 plus 30, 42 equals x minus 1. And now isolate the x. You could have just multiplied both sides by x minus 14. It gets you the same thing. I'm going to move that x over. Now I'm going to move the 42 over. 3x minus 1x is 2x. Negative 1 plus 42, that's a 41. And then divide both sides by 2 to get 41 over 2. That's our solution cut point. You look at the symbol in the problem, and if there's not an equal sign, you'll use an open circle when you label it on the number line. So first we find the solution cut points, then we find the denominator cut points. Well, what's the one number we can never have in the bottom of a fraction? 0. You can never have 0 in the bottom of a fraction. So x can't be positive 14, because if you were 14, we'd have 13 over 0. Punch that in your calculator and you'll get an error warning. Now, denominator cut points are always open circle because you never want a denominator of 0. So let's draw a number line and label the two cut points. Both of the cut points have open circles on them, but make sure you're putting these numbers in numerical order. You have 14 and 41 over 2. 41 over 2, if you wrote it as a mixed number, would be 20 and a half. That's the bigger number. Then 14. Go ahead and put infinity symbols on the arrows. Now we need to test an interval. I usually like to use 0 as the test point. So which interval am I testing? Well, 0 is always between negative and positive. So this is the interval I'm testing. If I plug a 0 in here and here, 0 minus 1 is negative 1. 0 minus 14 is negative 14. So is negative 1 over negative 14 bigger than 3? Well, negative over negative is positive. The fraction 1 over 14 is certainly not bigger than 3. And we said if there was no factoring involved, no repeated factors, then these intervals just alternate. So if this one's false, this one's true. That one's false. Write your answer in interval notation. Parentheses for the open circles. 14, 41 over 2. Be sure to put those parentheses. Coming over here. Parentheses 14, comma 41 over 2, right arrow to get out of the denominator, parentheses. Okay. Well, that's the last problem. So I'll thank you for watching, and hopefully wherever you are, the weather is better, or whenever you're watching this, the weather is better than what we're having right now. It's a cold, wintry, rainy day here, and I'm done for right now, so thanks again.